Hello and welcome to Lesson 5-2. Today we're going to talk about fractions and decimals. So to begin with, let's start out with a review of what a rational number is. If you recall, a rational number is any number that can be written as a fraction. Okay, so something like that could be something that we're used to seeing, like a 1/2. We could also write a number like 5 as a fraction. So this would be considered rational because if you recall, we can actually take 5 and write it over the number 1 so that it's a fraction. And we can also write numbers like, let's say, 2.4 as a fraction, because this right here would really be 24/10 or 12/5. So because I can write all of these numbers, 1/2 of course is already in a fractional form, 5 can be written as a fraction, and 2.4 can be written as a fraction. Okay, these are all considered rational numbers. Now, rational numbers can also be something that has a terminating decimal, kind of like the 2.4 example. But if I give you something like 1.4, 0.625, something like 0.75, notice that these all terminate. And by terminate, I mean that they end or they stop. They do not continue on, they just stop. We also have examples such as repeating decimals. So a repeating decimal, something like 0.6666 repeating, you could also rewrite this as 0.6 with a repeating bar over it. Now because it repeats, I can really write this as 2/3, or I could give you something that would be like 1.363636, and these continue to repeat, so I could just go 1.36 and put my repeating bar over the 36, and this right here I could always write as a fraction of 15/11. Okay, so I can take any of these terminating decimals or repeating decimals and write them as a fraction, and because I can do that, then these are all considered rational numbers. So for example 1, it says write each fraction or mixed number as a decimal. So if you recall, 1/4 really means 1 divided by 4. So that means I'm going to put my 1 under the division bar and my 4 out here. Well, 4 can't go into 1, so I'm going to plop a decimal point in, and I'm going to put in a 0. Now 4 can go into 10 2 times. 4 times 2 is going to give me 8. So I subtract these and I get 2. And 4 can't go into 2, so I'm going to bring a 0 up here and I'll pull that down, and 4 will go into 20 5 times. So 1/4 is really equal to my answer up here of 0.25. Okay, and we can do the same thing for part B. Now, this is really 1 plus 7/8, so I'm only going to do the division with a 7/8. So that means I'm going to take my 7 and divide it by 8. So here, 8 won't go into 7, so I put my decimal place in, bring a 0, 8 goes into 70, 8 times, which gives me 64. I subtract these, I bring down my 0, which gives me 60, 8 goes into 60, 7 times, which will give me 56, and I have 4, bring down another 0, and I get 40, and 8 goes in there 5 times. So to write 1 7/8 as a decimal, my answer then is really 1.875, because I have to then go and add a 1. I'm going to do the same thing with 3/10. This is really 3 plus 3 divided by 10. So if I take my 3 and I divide it by 10, I'm going to pull in a 0. 10 goes into 30 3 times. 3 times 10 is 30. Subtract them and I get 0. So now I have 3 plus 0.3, which is going to give me 3.3. And then my final example is 15/11. So with this one, I have 15, and that's going to be divided by 11. 11 will go into 15 one time. So I subtract that, I get 4. Now if 11 can't go into 4, but if I put in a decimal place, I can place a 0. 11 will go into 40 3 times. When I multiply 11 and 3, I get 33. And when I subtract these, I get 7. I'm going to have to bring down another 0. 11 will go into 76 times, which gives me 66. And I'm subtracting these, so now I have a 4. I'm going to bring down another 0, and 11 goes into 40. I've already done this, and if I continue to do this, what you're going to notice is that we're going to end up with a repeating decimal. So this is going to become 1.36 repeating. So I'll write that down here, 1.36 repeating. So when I go back and I look at all these decimals, decimal A right here, because that decimal ends, I would say that this decimal terminates, or it has an end. Decimal B also terminates because it stops. Decimal C terminates, but the second decimal B does not. This is what we call a repeat, a repeating decimal, because of the 0.36 going on forever. So in example 2, we're going to have to distinguish these. In example 2, it wants us to do the same thing. I want you to pause the video and then come back and double check your answers. So if you take 7 and you divide it by 9, you should get a decimal of 0.7 repeating. So this right here will be a repeating decimal. For part B, when I divide 21 by 22, I get 0.954, and the 5-4 are going to continue to repeat. So this here is also a repeating decimal. And then for part C, 11 divided by 8, this right here is really 1.375 if you divide that out. And this is going to be a terminating decimal. Now, in our directions, it says if the decimal repeats, state the block of digits that repeat. So my repeating portion of this decimal here in part A is actually 7. The repeating portion in part B would be the 5-4, that's the repeating block, and then C terminates, so it does not have a repeating block. Now for example 4, it tells us to write the numbers in order from least to greatest. When I look at these numbers, we have fractions and we have decimals. So when you are comparing numbers, sometimes I think it's easiest to change your fractions into decimals. So to do this, our 1/4 is going to become 0.25. We have a negative 0.2. A negative 3/5 is really a negative 0.6. And I have a positive 1.1. So hopefully at this point in time you can at least recognize the fact that the 1.1 being a positive number is going to be the greatest, with the 0.25 or 1/4 being the second largest. So now what I have to do is I have to figure out which one of these is my smallest. To do that, I kind of like to think about them in terms of them being positive. If these were positive, I would have 0.2 and 0.6, and 0.6 would be greater than 0.2. However, because they're negative, when I add that negative, the negative 0.2 is actually greater than the negative 0.6. So that means that the negative 0.6 is going to be my smallest. Well, negative 0.6 is really a negative 3/5. That's going to be less than my negative 0.2, which is going to be less than my 0.25, which is really 1/4. And this is going to be less than 1.1. Please take a quick second and try example number 5 on your own. Hopefully you rewrote your fractions as a decimal. If you did, you should have a negative 0.125, a negative 0.75, a negative 0.25, and a negative 0.375. So to put these in order, again, I think about them in terms of being positive numbers, and that means that the largest positive number is actually going to become my smallest negative. So if I do that, that's going to give me a negative 0.75 would be my largest. A negative 0.75 is going to be less than. My next largest number is a negative 0.375. So that would be this one. Then I have a negative 0.25. Well, negative 0.25 is really my negative 1/4. So I have a negative 1/4. And this is going to be smaller than my negative 1.125, which is really a negative 1/8. Now the last thing we're going to look at is changing decimals into fractions. And we have two different types of decimals that we're going to look at. First, we're going to look at a decimal that does not repeat. Okay, in other words, one that is going to terminate. So if I look at this example here, it says I have 0.43, which is read as 43 hundredths. Okay, so 43 hundredths as a fraction is really going to be written as 43 over 100 like this. So what we could have done is I can see that to take 43 out of a decimal, I would have to move it from the tens to the hundredths. So I'm going to rewrite 43. I move my decimal place 2 places. Okay, so that means I'm going to have to divide this by 100. If I give you something like 0.125, okay, to write this as a fraction, I'm going to move it my tens, hundredths, thousandths. So that means I'm going to write my number 0.125, and I'm going to remove the decimal and write it as 125, and then I have to divide that by 1,000. Likewise, if I have something like 0.7, this here, I'm only moving my decimal place 1 place, so I'm going to end up with 7 divided by 10. So let's go ahead and look at our next example. Example 6, I'm going to move my decimal place 2 places. So this is going to give me 112. And because I move my decimal point 2 places, I'm really going to divide that by 100. If I reduce this down, I know that both of these are at least divisible by 2, which will give me 56 over 50. And again, I know that I can divide these again by 2 because they're 2 even numbers. So this is going to give me 28/25. For our next example, I have 2.3. So I'm going to move my decimal place 1 place. So I'm going to take that and make that 23 and divide it by 10. For the next part, I'm moving my decimal place 3 places. So I'm going to make that 375 and divide that then by 1,000. And for my final example, again, I'm moving that decimal place 3 places. So that will give me 25, and then I'm going to divide by 1,000 again. Now the second type of decimals we have to deal with are repeating decimals. Remember, with a repeating decimal, like in example A here, when I have that bar over the top of the number like this, it really means that that 7 is repeating itself forever. So I would get something like this. Now with these type of fractions, we have to treat them a little bit differently. What I'm going to do is I'm going to set this stuff here equal to a variable, and I'm just going to use the variable x. So I'm going to say x equals 0.777, and we're just going to list a couple of them out. Then what I'm going to do is I'm going to see how many places I have to move my decimal place before I hit the end of the repeated portion. So here I can see that if I move my decimal place 1 place, I've captured all the numbers that repeat. Because if I move it 2 places, now I have 2 7s. So I just want to move it until I've hit the end of my repeating numbers of decimals. So next what I'm going to do then is I'm going to say 10x, and I'm going to do 10 because I had to move it one decimal place, and it's in the tenths, so now I have 10, and I'm going to say 10x then equals, so if I multiply 0.7777 by 10, then I'm going to get 7.777. Now what I'm going to do is I want to clear out my repeated portion. So if I take 10x equals 7.777 and I subtract this x value up here from that, so I'm going to subtract x, and we know that x is really equal to 0.777. What I'm going to end up with is 10x minus 1x will give me 9x. These decimal places, or the repeated decimal, is going to cancel, and I'm going to be left with 7. Now we have what we call an algebraic equation that we can go ahead and solve and get x by itself. And the x then is going to be equal to the equivalent fraction. So in this case, I really have 9 times x equals 7. I need to get rid of that 9 by undoing it. We undo multiplication by dividing both sides of the equal sign by that 9. So here, my 9x divided by 9 is going to leave me with just 1x, and then I'm left with a fraction of 7/9. So if you were to go and double check, 7 divided by 9 will actually give you 0.7 repeating. Now let's walk through this one more time with part B. So part B, this really means that I have 0.54545, and it's just going to repeat forever. So I'm going to rewrite this as x equals 0.545454, and then I'm going to see how many places I have to move that decimal before I start repeating again. So in this place, I see that I move it 2 places, or I move it to the hundredths spot. So that means now that I'm going to write 100x equals, and if I multiply 0.545454 by 100, I end up with 54.5454. And again, just like in the example or part A, I'm now going to subtract my x so that I can get rid of the repeating portion. Well, x was really equal to 0.5454 repeating. When I subtract these, I have 100x minus x, which is 99x. My repeated decimals are going to cancel out, and that's going to leave me with 54. Then I want to get that x by itself so I can see what my fraction is. Remember, this is really 99 times x. So to undo multiplication, I'm going to divide by 99. My 99s are going to cancel out here, and that's going to leave me with x, and I'm left with 54/99. Now, in this case, 54/99 will reduce down because 9 will go into 54 6 times, and 9 will go into 99 11 times. So my final answer would be 6/11. So 6/11 will give me the repeated decimal 0.54. Now our last example is going to be part C. Part C says that we have the repeated decimal 2.34. So this is really 2.343434. So I'm going to start out the same way, and I'm going to say that x is equal to 2.343434. When I go and I look and see how many places I have to move my decimal point before it stops repeating or starts to repeat again, I have 2 decimal places, which means that's 100. So I have 100x equals, if I multiply 2.343434 by 100, I get 234.3434. I'm going to go ahead and subtract x again from both sides so I can get rid of that repeated decimal. So that's going to be 2.3434. 100x minus 1x will give me 99x, and 234 minus 2, because we know that our repeated decimals are going to cancel, is going to give me 232. Now again, I have 99 times x. I will undo that multiplication with division, and I have to divide both sides. So my 99s are going to cancel, and that will leave me with 99, or x equals 232 divided by 99. And because I cannot reduce this fraction anymore, I'm just going to leave it like this. Please let me know if you have any questions. Otherwise, I hope you guys have a good day, and we will see you in class.